Hey everybody, it's Mr. Carr again. Today we're going to be looking at 4-4 day 2, and the focus today is going to be looking at both a phase shift and a vertical shift of a sine and cosine functions here. Okay, so the phase shift is basically telling us kind of like a horizontal translation. It's going to take the entire curve and shift it to the right or to the left. Okay, so we're going to look at this here. Any kind of so it says here between the horizontal position of a function and that of an otherwise similar sinusoidal function. So for example, if we look, this is our normal sine function right here. This difference, if I look at the tops over there, those maximums, it's shifting over a certain amount. Now, technically, every single point shifts that same amount. So this is also the same there. This point, where am I at? This point right here is shifting to there. Okay. So these are all moving the same amount when we do this phase shift. That phase shift is determined by the c value in this function. So we're looking at a times sine of bx plus c plus d. It is a combination of both c and b. So remember, b is the period. That affects that. But c is the phase shift. So c along with b, like they do the same thing together. So what we're doing with this one is, if we take the opposite of c divided by b, that tells me how much it's going to shift by whatever amount there. Okay. Same thing if I do cosine of bx plus c and then plus d. Okay. So c and b will do the same jobs in both of those. It's going to shift the entire sine or cosine function based on both b and c. Okay. So if b is 1, c is the only value that makes the difference. But if I increase b, that's making my period like shorter, like whatever it does. So it does that, and then I shift it. Okay. So it could do two things. So that's why both period and the c value there is going to affect the phase shift. D is our kind of displacement. It is our vertical shift. Okay. So that just means that that midline right here, okay, whatever's in the middle is determined by D. So maybe D is 0. That's what it has in this case. Okay. So D is right in the middle of those amplitudes. Okay. So we can take the whole thing, shift it up or shift it down, but that's determined by whatever that D value is. So before we go to an example, I like to go to Desmos, just kind of demonstrate with our phase shift a little bit more. Okay. So the blue graph is going to be my normal sine function. When I change this c, so I've got x minus c in parentheses, you can see how it shifts it to the right. So this is officially at x minus like 2. So that's moving 2 spots to the right like that. Okay. And you can see that. You look at it right here. Oops, close enough. This is at 0, 0. This is at 1.8 now. That's how far to the right I moved. I'll go the other direction with it. So now these are technically positive values inside. Okay. That value right here, 0, 0, is now to the left, negative 2, 0. Okay. So that's what we're looking at when we do our shifts. That's how it's moving. And again, it's also affected if I do my period. So normally, so if I have, let's see here, if I go back to 0, okay, close. Come on, right? Okay, we'll just do this. All right, so if I do this first, if I do a 2 in front, now I've shortened the period. Okay, I've made it condensed version here so that we have one complete period right here, but that's half of my normal one. Okay, so now when I take this and do my shifting, you can see how, like, since it's condensed and then I shift it, okay, it's not exactly matching up to the original, but that's because it's a like it is a I'm changing the period and doing the shift at the same time. Okay. So I just want to make sure we see how that works real quick before we get into the actual calculating of these when we graph this out. Okay. So our goal here is to state the amplitude, period, frequency, and phase shift. So let's start with that. So I'm just going to list those over on the side here. So the amplitude is just 2. I guess technically it's plus or minus 2. Period. Remember that is going to be related to the 5. So it's going to be 2 pi divided by that 5. So in 2 pi over 5 radians, it's going to go one complete sine function. Okay. Frequency, remember frequency is 1 over the period. Okay. So in this case, it's just going to be the reciprocal, 5 over 2 pi. Okay. And then the phase shift. So for my phase shift, we're doing negative c. So we could do negative pi over 4 divided by the 5 here. So instead of writing it that way, we're dividing by 5. It's the same as multiplying by 1/5. So this is going to be negative pi over 20. So let's start creating a little bit of the graph just so we can see where our starting point is when we look at this. Okay, so first thing is, I'm not going to like try to make it a condensed version. I'm just going to draw this curve every time. Okay, I want to make it as clear and easy to draw it out as possible. But what changes is all my numbers. For example, my amplitude goes up to 2 and -2. So I'm going to put those on there. My phase shift is negative pi over 20. Normally sine is starting at 0, 0 here. So that's a normally 0, 0. But because of the negative pi over 20 for my phase shift, this is actually starting at negative pi over 20. That's my first value there. For the rest of the graph, I want to model 4 more key points. Okay, so when you look at the normal sine function, it goes 1, 2, 3, 4. This one's the maximum, then it crosses again, then it's the minimum, then it's the maximum again, or sorry, then it crosses again. Okay, so that's what we're trying to model there. Now, when we look at a normal sine function, those are all equal sections. So I'm going to figure out how to do that, because if I know that this whole thing is 2 pi over 5, that means if I split it up into 1, 2, 3, 4 sections, then I can divide that by 4, or I'm multiplying by 1/4 here. That's going to tell me how much each jump is from those tick marks. Okay, so I can do that. I'm going to go ahead and do, was it the 2 pi over 5? I'm going to multiply that by 1/4. That's going to come out to 2 pi over 20, which is pi over 10. So again, what that means is pi over 10 tells us how far apart each of these key points are. So that's what I'm going to do. I'm just going to add that pi over 10, or in most cases, I'm just going to add 2 pi over 20 because it's already negative pi over 20 to start. So I'm going to add 2 pi over 20. So it gives me a positive pi over 20. Add another 2 pi over 20. That's going to give me 3 pi over 20. Add another 2 pi over 20. I get 5 pi over 20, which is going to be, if I reduce that, that will be pi over 4. And then I got one more. I got add another 2 pi here. I get 7 pi over 20. Okay. And so that's my graph. I'm going to help confirm that using Desmos here. So again, I've got 2x, or sorry, no. Yeah, we'll get rid of the slider now. We have a 5 here. And then that was plus pi over 4. And that was a 2 in front. Okay, so we can see how there's a change. We've got that stretching out because of that amplitude there. We've got right here is my negative pi over 20. Those 4 more characteristics I've got, it was pi over 20, 3 pi over 20, pi over 4, which is 5 pi over 20, and then one complete period is right there at 7 pi over 20. Okay, so that's what we're seeing here on that one. For my domain and range, my domain will just be negative infinity to infinity. Okay, unless there's a word problem, that should always be negative infinity to infinity, because officially the graph is going to go on for both directions. Range, however, is only going to go span from the -2 to 2. It's our amplitude is basically telling us our range there. Okay, and that's it for this one. So let's do one more together on this one. So again, state the amplitude. There's nothing in front, so it's going to be like a plus or minus 1, period. Yeah. Meant to do equal sign here. Period is going to be 1 over b, which in this case is 1. So my period is 1. Okay. The frequency is going to be 1, like reciprocal of that, so it just ends up being 1 again. And then phase shift is the opposite of this pi divided by 1. Okay, or it's just negative pi. And then the vertical shift. So vertical shift, remember that's going to be based on this plus 1 here, it's going to go up 1. Okay, so I'll just say plus 1, or I probably should say up 1. So it goes vertically up 1. Okay, so just like I did before, I'm going to go ahead and graph these out. Now, some people like to have with that plus 1, they still want to make this a 0 here. Personally, I like to make it a 1. Okay, still gets the same point across. So 1 is the midline. With the amplitude being plus or minus 1, that means I'm going to go up to 2, down to 0. Okay, It is a sine function, so I'm going to go ahead and do my normal sine curve here. Okay, and then my phase shift is negative pi. So negative pi is going to move to the left. So since my period is 1, I'm going to take that 1 and split it up into 4 sections here. Okay, remember, it's going to go from here to here. It's going to be 1 more. So I'm just going to take 1 and then multiply that by 1/4 there. So I get 1/4 every time. Okay, so that means I've got negative pi for my initial shifting, and then everything else is going to add 1/4. So 1 second here. Sorry about that. I just realized I made a mistake. I went way back here to period. This was messed up. Period is 2 pi over the b. So this is just 2 pi here. I don't know why I did that. Okay. So that changes a few things. Number one, frequency is now 1 over 2 pi. Okay. Phase shift is still the same. It's negative pi over 1. So it's negative pi for a phase shift. But when I do this, remember this 2 pi is being split up into fourths. Okay. So it's 1 complete 2 pi to go from here to here. So I split that into fourths. So I get, it will be pi over 2. Okay. So with a negative pi as my phase shift, I'm going to add pi over 2 every time. Yes. Yeah. Okay. So let's see, where am I at? So if I add pi over 2, let's see here. So this is the same as negative 2 over 2 right here. That's negative 2 pi over 2. So if I add pi over 2, that will be just a negative pi over 2. Then I add another pi over 2. That's going to be 0 here. Add another pi over 2. Gives me that. And then I add one more pi over 2. So that's going to be a positive pi. Okay. So that tells me my 1 period there. Again, what I officially did was because I just treated the phase shift as instead of just negative pi, it's also negative 2 pi over 2. Okay, so I did this as a negative 2 pi over 2. And then I added pi over 2 to that to get to each of these steps here. Okay, my domain and range. Domain again, negative infinity to infinity. Range is going to go from 0 up to a positive 2. And that's it. Okay. And I'll leave you with this example here to go ahead and try on your own. But that is going to be it for today. So again, the focus today was talking about these phase shifts as well as a vertical shift with our graphs. All right. Take care, everyone.